Hello everyone, in this part we're going to introduce the WLAN optimization background. As the WLAN repeatedly develops, more and more businesses are moving towards wireless operations. WLAN optimization is an important procedure to ensure the network quality, and the increasing number of wireless nodes exacerbates the difficulties of planning, deployment, and OM. And the WLAN networks nowadays is lacking of planning, no professional assessment and planning before selecting a site, no proper channel design to prevent the interference, and its lack of effective security controls in the design path. Except that it has complex WLAN configurations. The number of connected devices is increasing at an accelerated rate. Parameters to be configured are doubled. Except that it has no guarantee of reliability. Blind spots exist in the coverage area, serve wireless interference, and no guarantee of security. And the last point is difficult to OM the WLAN. Increased OM costs because of poor network quality. New OM challenges caused by network complexities. After knowing the background of the WLAN optimization, I think you have know the reason why we should optimize the WLAN right now. And next, let's see. To optimize the network, what's the purpose or what's the goal of the optimization? And for the users, the good Wi-Fi experience represents 4-bar signal, quick communication, non-perceptional roaming, and smooth internet access. To achieve this goal, let's see what we should do. Firstly, WLAN optimization is a series of dedicated optimization operations conducted by wireless network engineers after user surveys and network testings. Network optimization improves user experience and reduces the OM costs. Let's see the whole procedure of a network project, from overall designing to site survey to detailed designing, deployment, acceptance, evaluation, and optimization. You can find optimization is at the last step. During the use of the network, we can find some shortages of it. And based on the shortages or based on the new requirements from the users, we can evaluate and optimize the network we're using. Okay, and here let's see. In a real network, at this page, it shows us some factors affecting WLAN user experience. For example, weak signals. And weak signals could be caused by blind spots or some offline APs. Except that complicated authentication will also affect the user experience. For example, slow IP address opening, because since it takes long time to open the IP address, so the authentication period will take long time, right? And slow web authentication page display, dropping of .1x authentication, and so on. And the last is the internet access jitter. For example, insufficient egress bandwidth, broadcast packet flooding, external interference, interference between APs, AP performance limitation, and so on. And from this page, I think you can find that the user experience of a WLAN could be affected by a lot of possible factors, right? Okay, and next, let's see. To optimize the WLAN, we can do it from different aspects. For example, first is the network optimization. We can optimize the network architecture, the VLAN devices in the network, device security designing and optimization, and the device reliability optimization. And actually, you can find all these optimization points are related to the weird network. So to optimize the WLAN, not just maybe change some configurations of APs or ACs, it has a fixed relation with weird network. Okay, and next is a configuration optimization. We can optimize of the RF parameters, authentication policies, security policies. And the next is capacity optimization. For example, the adjustment of AP quantity, upgrades, and replacements. Next, about the coverage, we can maybe optimize the AP locations, AP quantity, antenna locations, AP transmit powers, and so on. And about the channels, we can maybe adjust the channels of the APs to reduce the interference, right? And for the client we're using, we can also, for example, update the driver versions, right? Or primary bands of wireless NICs can be adjusted to improve the user experience. Okay, so this is about some aspects that we should focus on when we do the WLAN optimization. And next, let's see what we can do. For example, for the architecture optimization, how can we adjust the architecture of the network? For example, the networking modes we use. We can use AC and FIT AP networking, or we can use mesh networking. We can use FAT AP networking, right? Based on the situation, you can choose different networkings. And for the AC deploy modes, we can choose direct connection or bypassing modes, right? If you use a direct connection mode, you should consider the forwarding performance of the AC, because all the traffic should go through AC. And make sure that AC could not become the bottleneck of the data forwarding. And about the reliability, we have some technologies. For example, you can use AC hot backup, right? You can use virtual AC. You can use AC cluster technology. Right? These technologies we have already introduced in the former contents. Okay, and the next is device models. For example, APs or ECs or switches. You can elect the models of them. Okay, and then next, network planning optimization. For example, the networking mode is layer 2 or it's a layer 3 networking. Right? If it's a layer 2, means the AC and AP are in the CM network segment. Right? Okay, and the data forwarding mode is direct connection or tunnel forwarding. Direct connection means after receiving the data, AP will directly forward the package based on its local forwarding tables. While the tunnel forwarding means that all the traffic will be forwarded to the AC through the type of tunnel, and AC will forward the package. Okay, and about the WLAN planning, we can think about the management VLANs, service VLANs, and to separate them. For the SSID, we have, for example, we have employee, we have visitor SSIDs, and different SSIDs for different types of users. And the security policies we use should be considered. Okay, and next is about the weird network function optimization. For example, the broadcast domain controls. To control the broadcast domain, basically we use the VLAN. Right? We use a VLAN to separate the broadcast domain. Except that we can use user isolation, we can use port isolation, these kind of technologies. And the next is address port capacity. At least that the available IP addresses in the address port should satisfy the requirement of the users, right? And for example, about the DHCP, we can maybe adjust the aging time. We can adjust the aging time, or we can maybe enable the DHCP snooping to improve the security, right? Or we can maybe adjust the leads of the IP addresses and so on. Okay, this is about the network optimization, focuses on the weighted network. And next is about the configuration optimization, focuses on software functions based on parameter settings, have implications for the implementation of a function. And function configurations vary in different scenarios. You can adjust the configurations to improve WLAN user experience. For example, we can maybe set the access control for terminals with weak signals. We can limit the access of the low-speed terminals. In this way, we can improve the air interface usage. And for some low-speed terminals, they have already accessed the network. We can forcibly bring offline these kind of terminals, and can also improve the air interface usage. And next is about the roaming technology. We can adjust the roaming configurations so that terminals can roam to neighboring APs with better signals in a timely manner. Okay, this is about the configuration optimization. And about this part, let's see a question. Which of the following factors could affect the WLAN user experience? A. Slow IP address obtaining. B. Interference between APs. C. Link support. D. Broadcast packet flooding. And obviously, all of them, right? All of them could affect the user experience. So we choose A, B, C, D. Okay, that's all for this part.